So today I'm gonna be studying Sklearn, and I'm also gonna convert the merge sort algorithm from JavaScript to Python. I don't think I'm gonna do the other ones for now, that I was trying to figure out how to do in Python from JavaScript because there's too many things to do. So maybe at some point I will convert the remainder ones. I'm also gonna put some music behind the scenes here, but I'll turn the volume down on the string, so the music doesn't go into the VOD. And let me put a timer here. I think I'm gonna spend 2 hours. I think I'm ahead of schedule to be able to finish all the courses, which seems kind of impossible to me because it says that it is 793 hours total, all the courses. But I think since I'm not gonna do some of them and other ones, I skipped a bunch of things because I thought it was redundant and I wanted to see new things. I think I'm gonna be able to finish all the ones that I want in under one month, and I'm probably ahead of schedule. So I think I'm gonna spend more time today because of that. So here I have a small script for analyzing, making a convolutional neural network, and I think I'm gonna use this one to. I already opened up a bunch of the tabs here, but I'm curious to see where these main functions come from, this train test split, this flow from directory, sequential, conv2d. These are basically the layers, the way that the network works. And I want to understand how the source code is structured. I'm not sure if that's possible because of the way they did this. It might be impossible to just see it, just understand it by looking at this code, because they have something on the API that is outside of the computer. I don't know exactly how it works, but I want to investigate and see if I can extract any valuable information. And then obviously the goal is to get the fundamental parts of this and build my own library from scratch, which I already have some of the equations for derivatives in another project. So here I have the merge sort. I don't remember really well how the merge sort works. I think it compares two elements that are beside each other, and if one element is bigger than the other one, then it flips them, and it does this for all the elements until they are all sorted. So this one, yeah, I don't think I need to import this. It's probably just to test the time. Here, find the smallest, and this is how long it takes. So yeah, definitely how long it takes. Sorted list. So array view. Oh, actually, is a function. So I need to think about another name to put it. I think I will put it array just to save time of having to think about this. Start goes 0. Oh, keyword arguments have to be the last arguments. Oh, the other one is a keyword, so it doesn't matter. And equals array dot length. Oh, and it has to be like this because it's different. Hmm. This is the problem. Also happened on the other one. Which is different for JavaScript and Python, the way that it recognizes the variable here. So I think what I might have to do is create this variable as a global variable, which is not ideal because it's not efficient in memory. Unless I can think about another way, but I think I'll do this for now because I don't want to spend a bunch of time. If I try to do it another way, I'm gonna have to research. So, and then I'll spend a bunch of time researching. Yeah, I think this is gonna work now. This is from GitHub Copilot. The suggestion. Sometimes it's interesting to see what it comes up with. So the function starts here, start, length, and minus start. True array. I'm not sure how this works actually. So it's slicing the array from the beginning to the end. But I'm not sure how the two dots here work. If this is an object, and then it's returning this. So the slice is a delta start, is a function, delta start, delta end. And then it runs recursively, I think. Yeah, it calls the function again with start plus delta and start plus end. I'm not sure if it's gonna be possible for me to do this on Python. Probably gonna have to change things. The get index, real index, start plus index. Yeah, this is super complicated as well because this function returns this other function here. It calls this with the delta, which is gonna loop through this until probably sorts all the elements. And then at the end it calls this one, I assume. Or maybe it has to call this one time. Because then when does it stop calling? That's the thing. So this is the lies. True array assumes the final array. This is a slice and this is get. It's getting the index. So return real index if real index is smaller than end and real index bigger or equal than start. Returns array real index. Otherwise undefined. So if the index is in the middle, it's gonna return the element, the array, the element in the position of the index. Otherwise, it returns undefined. Yeah, I'm not really sure if this is gonna call here recursively until it gets to a certain point, and then it calls this function. because this one is encapsulated in this one. No, which is encapsulated in this one as well. And maybe I should look at the other ones because this seems like it's gonna be too difficult to. Or maybe I should just try it out, writing exactly the way that it is there. It's probably not gonna work. Oh yeah, doesn't have arrow functions. So I wonder if I can do this. Or maybe I should do def. I should do it here. Yeah, I don't understand this syntax really well. I think I'll read the other ones and see if they are easier to understand. Because then if I understand the other ones, it might get easier to understand this one. Oh, I guess this is just a part of the. This is not the algorithm itself. That's why I'm not understanding this. This is just used for the other ones, probably. There's this concept that I learned that is called currying, and it's pretty much returning a function instead of another function. And in that way, you can call the function, you can get partial values each time you call the function. And I think that's what's happening here, where you have three different functions inside of this one, but I'm not really sure if that's the case. Let me see if I can do the other one. It's easier. It's too complicated. I'm just gonna go into the Sklearn stuff. Think I also forgot here, or maybe it works this way, but I think here I'm gonna have to return probably. Oh, and doesn't have. So if A bigger than B, I think I can return with parentheses, but maybe I need the curly braces. Or maybe I should just do. But if I don't do it like this, then I'm not sure if it's gonna work the same way. I was thinking about doing this if else statement outside and returning something else. Or maybe returning the different values depending on the if statements. Then else. Else. Yeah, should probably do the return outside here. And see if I do like this, I can do it. That doesn't work. I think I'm gonna leave it like this then. Else. Oh, there's another nested statement there. Else if A is smaller than B, return -1, else return 0. I think this is the same as it is the other one. Hopefully this other is easier to do it. Yeah, here's not gonna work as well. I'm gonna have to do the global variable, I think. Because I can't do these functions as arguments in Python. And then compare should be default compare. I think I can do them on the same line here. How can I slice on Python? I think it's the same way, but you just do it like this. Yeah, but then how? Oh, I forgot the. How do I pass the array there? I think I would just look it up. Hmm. I think I need to put the array in front and then slice in the. Yeah, just like here. So it's gonna be array like this. So divide, pivot. Oh, math.floor. Maybe it's math like this. So why is not working? Oh, there you go. Guess just VS Code. Or maybe there was a typo there. Didn't see it. Left equals. So this is recursive as well. And looks like GitHub Copilot already knows. Sorted. I also did the Rust course on the ZTM stuff, and I really enjoyed the language for some reason. I think it's the most difficult language I I don't want to say that I learned because I don't really know how to code. I just know the syntax, but because I haven't practiced with the language yet, but I think I might study that more as well. It's very similar to C++ and is also similar to TypeScript as well. So I think it might be worth it to investigate it further. So now it's looping through K. And length is here. It's probably the same thing here that is written here. Let's see. If I smaller than length dot left dot length, uh, it's probably the same thing, but it's written in Python here. And then it's returning this new one. So this is the sorted array. So it's taking rounded the rounded number of the length divided by 2. So the middle of the array is this pivot, and then it's calling the left with the start plus pivot, and the right with the yeah, the start is the start here for the left, and the end is the start plus pivot. And then the right, so it's taking the first half of the array, and the right is the other half. Then it takes the length. If I is less than the length of the left, and compare left right. So it's comparing this, is running through this here with these two variables. Then it pushes the left through the other array. So if it meets the condition, it pushes the left, and now it pushes the right. So it's pretty much comparing the two elements, and then pushing whichever one is bigger into the right and the smaller into the left, and it does this recursively, I think. Not recursively, it does this on the loop. For all the elements, I think. In the initial array. But I'm not sure if this is the same here. I guess it is the same because I don't need to specify, I don't need to make k++ since the loop already does that. That's the only difference. Yeah, the only difference is the order here, I think. Maybe should erase this one and do exactly like it is here. I think that's what I'm gonna do, just so it's the same. If I smaller than length left, and yeah, and I think Copilot already knows. It's slightly different. I'll compare here. I think now it's the same. Yeah, now it's the same. And then at the end, return sorted. I think I'll just do this one for now, and then I'll think about it if I want to do the other ones later, in another time. I think I'm also probably, I'm not sure, but I think maybe I'll search for the other algorithms that they talk about in the Turing sites, which is Prim's algorithm, and then there's other ones that I don't remember really well. I think I'm gonna do the other ones later. I'm gonna study the Sklearn stuff. I'm still debating with myself if after I finish all the courses, I'm gonna continue doing the decentralized exchange project, which is doing animations based on the relationship between reserves on different exchanges and the addresses on the blockchain, which I think is really interesting. But I also want to do a bunch of Kaggle competitions, so I kind of memorize the steps because I already know the steps. But if I think off the top of my head which libraries I have to import and which methods I have to do, I still don't remember specifically. I know the overall picture of the stuff that you have to do is pretty much you take the data set, then you clean it, remove or replace the null values with the medium of the columns. Then you take the columns that are numerical and you do one-hot encoding, which is pretty much transforming them into matrices of zeros and ones. Then you combine that with the other numerical columns, and then you split the data in between test and train. Then after that, you feed the data with an algorithm and do these layers to set up which model we're gonna use and which gradient descent method you're gonna use. And for vision, you have to put it between the filters of the image to clean the image and to reduce the complexity so the calculations are faster. Which the math is a little bit complicated. It's a lot easier to do it with this sequential stuff and these methods, but I did a brilliant .org course, and they talk about the math, and it's a lot more complicated to understand the math. So to do it with the math is probably going to be a lot harder, I think. Then you build the model, then you fit the model based on the tests with the target, and then after that you test the model. Yeah, you train the model first and then test with the other Y. And I think that's pretty much all you have to do. And then after that, you save the model into a pickle using pickle to put it on a binary file or use the some function. I think it's job save or something like that from Keras or TensorFlow. But I still don't remember the methods by memory and the stuff that I have to import and the steps. So I think it will be good to probably do some Kaggle competitions until I get very used to doing this pattern. And then only then after that, I start building my own library, trying to decompose this stuff into the mathematical equations and try to build things from the ground up. Because I don't want to be trapped with, not trapped, but confined to the stuff that they do behind the curtain with Sklearn and TensorFlow. Which I'm also not sure about because it might be just a waste of time because these people are getting paid and they're probably very good. They're probably the best in the plant, to be honest, at building this stuff. And they have teams of people doing this and maintaining this stuff, so it might be a waste of time to build my own library, but I think it's worth it because it allows to have more flexibility and trying to build new things. So you have to decompose into the primary formulas to try to. My idea, I think, is to try to create a geometrical model, something that is more related to the laws of physics. Because that's the biggest problem I have so far with this stuff is that it doesn't address the issue of the relationship between data and the assumptions that are made before you get the data of the connections. So it's a lot of practice, not a lot of practice, a lot of experimentation. You're pretty much just guessing. I think that's right now that's what mainly machine learning is. You're just getting a bunch of data and then feeding the functions into the data, but you're not capturing the fundamental aspect of the relationship between that data. And that's what I want to try to do, just to implement physical models and combine that with machine learning. So pretty much get geometry and some aspects of space-time and general relativity and stuff like that, Maxwell equations, and then put that into machine learning. So I not only have the relationship between data and I'm trying to fit the data into the functions, but I also have the relationship of the data with the physics models of space-time. And that's gonna take care or increase the probability in my mind that the fitting of the functions is gonna be more resilient than if I just fit the data. But the only way to do that, I think, is to deconstruct this stuff and build my own library. So I have the formulas and I'm not confined into calling the functions like this with the Keras layers. And because TensorFlow is so big, the library is kind of hard to think about which way is the best to explore the source code. I think I have the picture. Maybe I should open up here from the other project that Vivex helped me do it. I think it's this one. Yeah, so this is the basic version, I think. Or maybe I del oh, it's this one. Yeah, I couldn't do it on the on PNG format because it was too big. So that's pretty much the relationship between libraries in TensorFlow, which is absolutely insane. Yeah, but I think a lot of these libraries are also for the tensor stuff and not necessarily to build the model. And I think TensorFlow is very similar to. I think it's pretty much the same as NumPy, but the only difference is TensorFlow is better for computing in GPUs, I think, or something like that. Yeah, I've seen this lazy loader somewhere there. And this is connected through this. So Python framework.ops. Python. I don't see framework there. Oh, here. And maybe I can do this looking at the PDF and also open up the files here. OPS. And so this is lazy loader here. Also, I think I'm gonna close the other ones and I'm gonna start from scratch so I don't get confused on which ones I'm doing. But I wanna see how the train task split works under the hood. And maybe the compile as well is interesting because I want to understand how the formulas are. Especially, I think the most confusing part is the dimensions of the matrices, depending on the inputs and the outputs you want, and how the calculations are done under the hood, depending on which model it is. So maybe I'll close these ones. Oh, here was the lazy loader that I was saying. So this one is connected to this one. This one's calls these ones, I think. So I have this here and the lazy loader here. And I think it goes through this one. And this one seems to be the one that is one of the final steps. Eager execute, transfer framework constant OP. Arrays OPS, then goes through here. It's difficult because the file is so big, it's kind of awkward to go from one to the other one without losing the one that I began. Data to structures. So it looks like this is the final one. Or maybe not. Yeah, this is probably the final one. Or this one. Yeah, this also looks to be one of the final ones. So I'm probably gonna look at this file as well. And this one is tensorflow.python.data. Which is also, I'm gonna look at this one first. But I'm gonna open this first. So here, Control B to go to the source. And I'm also gonna look at maybe the fit is better than the compile. Compile also looks interesting, so. Or maybe this Atom is actually better. Atom is pretty much a gradient descent technique that I think it randomizes the descent to the local or global minimum or maximum. I cannot find declaration. Maybe optimizers. And Keras is true generic. Yeah, I think that's how I got to the lazy loader. I was trying to look at the Keras stuff. And I think this is the thing. This is why it might be impossible to look at the source code just by doing this. You might be getting from something external, making a request or something like that to TensorFlow. So I think I need to look at this lazy loader here. So I'm gonna close this one. Let me see if I can go to the fits. And there's so many. Let's see the compile. I think it's this one. It's probably the one that is being used there. I'm definitely gonna look at this. So let me start with this one and then I will go into the other ones. Just so I don't get lost because there's so many functions. So this is on sklearn.model_selection.split. The other issue is that PyCharm doesn't show a lot of the functions because they are written in C Python, I think. And then PyCharm doesn't show what's happening. And this file is huge as well. Split the data based on a preset strategy. So it uses collections, iter-tools, math, numbers, ABC, inspect, scipy, special. I think scipy is the core fundamental library from all the other ones. It's the one that has probably the things more closer to the math, I think. It might be worth studying it as well, more in depth later. Base class for all cross validators implementations must define iter masks or iter includes split. Generate indices to split data into training and test sets. So it takes X, Y, and groups. X array-like of shape, n samples and futures training data, where n samples is the number of samples and n futures is the number of futures. So it's an array with two shapes, samples and futures, with the shape of samples and futures. Array-like of shape and samples. So it does they need to have the same dimensions for the matrix multiplication, I guess, later on, or vector multiplication. The target variable for supervised learning problems. Groups, array-like of shapes, and samples default known. Group labels for the samples used while splitting the dataset into training test sets. Group labels for the samples used while splitting the dataset into the training test set. So I guess this is for when you want to do batches or something like that, where you're not gonna train in one sitting, you're just gonna do batches so that you don't overfit or decrease the chances of overfitting. I guess the biggest problem I have with this way of doing things with using this library is this thing about overfitting or underfitting. That I don't really buy the scientific paradigm of the way that we think about data and the cause and effect relationships of things. I think the probabilistic model is not it definitely seems to work very well, but I think it's missing something more fundamental. And the biggest problem is you can never really prove unexpected outcomes. So the whole paradigm of probabilistic and statistic thinking is based on the assumption that the density of observation of a reference frame determines the geometry of space-time. And that's always relative to the observer. That's the problem. It's always relativistic. So if you're flipping a coin and, for example, and you think that it's 50-50% the chance, and you get heads 1 million times, at what point you're gonna change the distribution of the probability in order to fit what the new experiment is presenting to you? So there's always this problem where you have this relationship of the density of observation, the frequency of computation, relationship to space-time, and the probability of certain outcomes, I think. And I think this way of doing things misses that because you're just capturing the data and you're assuming that the data you have is deterministic. which is not the case because things are always moving and data itself is always a simplification of the overall complexity of the structure of space-time from which the data appears. So it doesn't make sense to get a bunch of data because you're always going to be overfitting to some degree or underfitting, regardless of the amount of data. It's more a question of the flow of data and the physical parameters that create the connections between that data. I think that's what the models are missing by doing things this way. But obviously it seems to work to some degree. Obviously it's working on games, so yeah, so that's why it might be good as well to learn this paradigm first before I try to make something that is different. So at least get good at the models we have today. It's probably better. Checks consistency length, passes through none, and ensures that everything can be indexed by converting sparse matrices to CSR and converting non-iterable objects to arrays. Iterables. List data frames and the array sparse matrices. List of objects to ensure slicability. Returns result list of and the array sparse matrix data frame or none. Returns a list containing indexable arrays. NumPy array sparse matrix or data frame or none. So result equals this other function in a loop of the iterables, which are the arguments being passed through this pointer, I guess. A pointer, I think, is a reference. I still don't know very well the difference between pointers and references, but I think pointers, like the name says, is pointing to something to memory and it's not using the original thing. It's just using the pointer to that memory and doing calculations so you don't lose the initial value, the initial place in the memory, let's say. It makes things more efficient, I think. Ensure iterable supports indexing or converts to an indexable variant. Convert sparse matrices to CSR and other non-indexable iterable to arrays. Is there a fan? That's the issue with exploring the source code, is that each function has a bunch of other functions, so we have to go. There's no way around it. So it's passing the x, y in groups to this function, I think. Yeah. No, it's passing the x. So it's passing each value of the initial matrix, the initial x part of the data sample, into this one. It is interesting that here it says that is a list data frame and the arrays are sparse matrix. And I think here is passing one value, the other one. It's gonna pass x. So maybe the initial one has to be, because it's saying that has 2 dimensions here. So maybe it's a list of lists. This is not the one that I'm using here. So it's a different one. So maybe it accepts a list of lists. It just says array like of shape and samples and features. And maybe it's passing to the portion of the data frame. And then it passes here. So X is a 2D thing. So it's like a nested for loop between functions. Where this takes oh no, X is the 3 values, I think. Yeah. Because it's passing these 3 values here. Now I think I understand. So this X is equal to X, Y, and the groups. And it goes through this function for each one of them, which is the task, the target, and the groups with the labels. Ensure it both parts indexing requirements. Okay. And then it calls this one SP. What is SP? Oh, sparse matrices. Comes from the SciPy library. It's probably being imported in the beginning of the file. Yeah, scipy.sparse SSP. So it's gonna call this method on the sparse matrix to check if it is a sparse matrix or not. And if it is, it's gonna return iterable to CSR. So it's gonna convert from sparse matrix to CSR. If it's not, as attribute get item or as attribute iterable ilock. So if it's data frame, returns the iterable. If it's none, returns the iterable, and the default is NP array iterable. So convert to either NP array or to CSR if it's a sparse matrix. So I have to see what this sparse matrix is. Yeah, so it's pretty much checking if it is a sparse matrix or not. Then if it is, converts to this. I think is this the first one. Convert this matrix to compressed sparse row format. If copy equals false, the data indices may be shared between this matrix and result a CSR matrix. So I'm gonna look sparse matrix and what's the name of the other one? CSR. I think I'll be right back. Let's see how much time I have left. I'm 55. I still don't understand really well how the long short-term memory, or LSTM, works, and how the recurrent neural network works. And I think that's the one that was used in chess. And then for poker, I think it was Monte Carlo policy with regret minimization. A combination of that, where you create a global state for both players, and then you achieve Nash by doing calculations like that. Or something along these lines I don't really understand really well. But I'm thinking about why does that work? And I think the reason why it works is because games have a confined space, is a fixed rule set in a confined space. So I think there's this fundamental relationship between the density of observation or computational frequency and data. And I think the reason why neural networks work today and didn't work before, because they have existed for a long time. I think the main difference is the density of data we have now. So I think this might be related to gravity as well. Because basically we're not achieving anything new with machine learning, we're just becoming better at gathering more data and feeding that data into these models, which create an approximation of a function that closely represents the relationship between the data, because we have more density of information. So that, but the fundamental problem is that this gives the illusion of predictive capacity, let's say, but in reality is missing the fundamental aspect, I think. But it might be enough. It might be just a matter of understanding the relationship between the frequency of computation and how reliable that prediction can be based in relationship to the frequency or the density of information. Because it might get to a point where it's just irrelevant because it's computationally reducible. So it doesn't really matter to focus on that, because you're never going to be able to predict outliers with the scientific paradigm. Anyways, so it might be what's happening right now, I think, where you just have more density of information, so you can make better predictions because of the density of information. And it's not like the machine learning algorithms or anything special. It's just fitting functions into that density of information, and the predictions are better because of how much information there is available. So at some point, the information reaches a critical mass of complexity that is not important anymore to capture the underlying fundamental principles underneath the creation of the data, let's say. And because it doesn't matter anymore, I have so much data that even if our functions are overfitting, you're still gonna have decent predictions because of the frequency of computation you're achieving. This is probably what's happening now, I think. And then with quantum computing it just gets exponentially better at doing that. But then the issue with that is that it creates a self-fulfilling prophecy, because the data is always coming from a place that no one understands. And then if you miss the fundamental principles from which the data is being created and you put all these assumptions, you run the risk of being misaligned with the actual movement of the universe. And if you have exponential power, the differences increases the tension, which creates the self-destruction of the social structure, I think. So that's the biggest problem, I think, here. So it might be worth it to try to approximate the understanding of the difference based on physical principles, like the relationship of space-time, gravity, and the electromagnetic fields and how they correlate with each other, to try to capture something more fundamental than just the density of data itself. And instead of trying to overfit, not to overfit, but to fit the functions into the data sets, trying to make them like a middle way between the gravity and all these physical relationships and the data, and trying to calculate the distance between the predictions of the data and the physical, what just the pure simulations of the physical fundamental principles would give, and then create a tool around that maximizes the chances of correcting the overfitting of the data based on these physical principles. I think that's probably the best approach that I can think. If most of the elements in the matrix are zero, then the matrix is called a sparse matrix. It is wasteful to store the zero elements in the matrix since they do not affect the results of our computation. The why we implement these matrices in more efficient representation than the standard 2D array. Using more efficient representations, we can cut down space and time complexities of operations significantly. We have discussed at 4 different representations in following articles. In this article, you will discuss another representation of the sparse matrix, which is commonly referred as the Yale format. The CSR compressed sparse matrix, or the Yale format, is similar to the array representation discussed in set 1 of sparse matrix. Represent a matrix M times N by 3 1D arrays or vectors called as A, IA, J. Let N and Z the number of non-zeros elements in M, and note that zero-based indexing is used. The A vector is of size NN Z, and it stores the values of the non-zero elements of the matrix. The values appear in the order of traversing the matrix row by row. The other thing that I'm thinking about is that there's always this relationship between geometry and probability as well. Because in a way, geometry is the paradoxical point of the hard problem of consciousness, where the scientific paradigm and the philosophical paradigm, the religious paradigm collapse. It's like the wave function collapse. Because pretty much, I think statistics and probability is the belief that space-time follows this geometry and probability. Probability is the 4D version of geometry, let's say, of matter in the present moment. So it follows the laws of physics based on the gravity, and the past has a cause and effect relationship, and the probability of things is equivalent to the potential of the geometry in the space-time, I think. And I also think there might be a relationship between the complex plane and the space-time based on that, because the complex plane is probably a higher dimensional plane from which space-time emerges, I think, because it's fractal by nature, I think. So I think the challenge is figuring out how gravity is connected to the complex plane and the geometry of space-time in relationship to the density of information, in relationship to the reference frame of the observer. The sparse matrix is pretty much a matrix with a bunch of zeros, and then the C whatever is the compressed version of that to optimize for memory, I think. So this is what this is doing here. I'm gonna close this one, I think. Go back to the other ones. So indexable, make indexable. So if it is a sparse matrix, it converts to this more efficient version. If it's not, converts to NP array. I basically doesn't want to convert this sparse matrix, I think, because it might be, yeah, it's less efficient if you have a bunch of zeros to make the equivalent in NP arrays. It's more efficient to convert to the compressed version, I think. But the other ones is transformed into NP arrays. And this is the problem with PyCharm, is that it's just going to show this pass here. But in reality, there's a function here. It just doesn't show because it's written in C, I think, or C Python. And PyCharm doesn't show that, I think. So I think you can close this file as well. Keep reading this one. So it converts all the matrices into NP arrays, or the compressed version of sparse matrices. Then the indices are equal to np.range num samples x. NP range, I think, creates an array based on the range of the matrix here of the x. There are a number of samples in an array like x. So if it's not an NP, it's going to throw an error. If it has the array property, it's going to convert to this. It's probably a pass function. Yeah. Yeah, the other thing is that NP arrays have a default property, I think, is int based on the operational system. If it's a 64-bit operational system, the array is going to be 64, int 64. And if it's 32, it's going to be int 32 by default, I think. But I'm not sure if this is converting the data type. What is a singleton array? A singleton pattern in Python is a design pattern that allows you to create just one instance of a class. Throughout the lifetime of a program, using a singleton pattern has many benefits. A few of them are to limit concurrent access to a shared resource, to create a global point of access for a resource, to create just one instance of a class throughout the lifetime of a program. Different ways to implement a singleton. Singleton pattern can be implemented in 3 different ways. They are as follows: module level singleton, classic singleton, Borg singleton. All modules are singleton by definition. Let's create a simple module. Classic singleton creates an instance only if there is no instance created so far. Otherwise, it will return the instance that is already created. Let's take a look at the below code. So, this is to get the number of samples from the X. And samples length. I better to copy from here. Ensemble means a group of elements viewed as a whole rather than individually. An ensemble method creates multiple models and combines them to solve it. Ensemble methods help to improve the robustness, generalizability of the model. In this article, we will discuss some methods with their implementation in Python. For this, we choose a dataset from the UCI repository. Basic ensemble methods. Averaging method. It is mainly used for regression problems. The method consists of building multiple models independently and returning the average of the prediction of all the models. In general, the combined output is better than an individual output because variance is reduced. In the below example, 3 regression models, linear regression, attributes, random forests are trained and their predictions are average. Final prediction output is spread final. So ensemble is pretty much when you take a bunch of them and combine. So this is preventing to get the length of the symbols. And it's callable. Then whether the object is callable, some kind of a function. So this checks to see if it is a function. All the classes are callable as instances. So it's checking to see if it's an array or a matrix and not the assemble, which is a method of the combination of different models, I think. Yeah, then it's gonna throw this message here. If it doesn't have length and doesn't have shape attribute, if it has attribute array, so if it is an array but it doesn't have these properties, it turns into an NP array, I think. And now let's type error message. If it has shape and dot shape is not none, 0, raise type error. Okay, so if the shape is 0, it turns the singleton array stuff. Check the shape is returned in integer or default length. Desk data frames may not return numeric shape 0. If is instance x.shape 0, numbers.integral, and x.shape 0. So it just returns the length after it passes all the checks. And it creates the range of the indices based on the length of this array. For test indexing self.iterTest masks. So this is this function right here, I think. Yeah. In train index equals indices NP logical not test index. And uses an yield, which is a generator, and is used to optimize memory because it creates one instance at a time instead of creating the whole loop at once, I think. Since subclasses must implement either iterTest masks or iterTest indices, neither can be abstract. So I think what this is saying is either gonna implement one or the other. And it can't be abstract because when you have an abstract, you have to implement all the functions in the abstract class, in the other class that is going to inherit from the abstract. So if it's going to implement either one or the other, it can't be abstract because to be abstract it has to implement both, I think. But I'm not really sure about that. Generates Boolean masks corresponding to task sets. By default, delegates the true iter task indices. Task index in self iter task indices. So this calls this other one. And then creates a task mask of NP zeros, the length of the X with Boolean types. So this is gonna be zeros and ones, I think. Maybe. And it's kind of hard to understand. Generates integer indices corresponding to the task sets. Turns the number of splitting, iterations. I think this is something else. Return the array of given shape and type filled with zeros. Oh, so whenever you have a position here, it creates the whole matrices with zeros, and then whenever you have a position, it makes it equal to 1, I think. And then it yields that vector. I'll have to spend some time thinking about this because it's kind of hard to understand. So it's looping through this test mask here at the end of the day. Yeah, so this creates NP zeros. So it creates an NP array with the length of X with zeros. But then to understand what this is, it's kind of hard. I guess this is just the indices of these arrays here. These matrices, the X, Y, and groups. But it's weird because this just raises an not implemented error and doesn't have anything else here. I assume it's probably the PyCharm thing where it doesn't show the function. Because otherwise it doesn't make any sense. Generates integer indices corresponding to test sets. Yeah, I think that's what's happening. So this generates the indices of integers that correspond to these matrices here. Yeah, so I think it's converting the whatever arrays exists here into zeros and ones, and is yielding this test mask to this. And then it's gonna loop through this new array here. And that's why it's using this logical NOT. Because the training index is gonna be the indices, which is this array, in whatever position you have ones in the other array. And the task is gonna be, so it's creating another matrix, creating other matrices of zeros and ones to use that matrix to filter the original ones, and then it creates the two other ones through this process. I think whenever it has zeros, whenever it has ones, it's the training index, and when it has zeros, is the task index. Or maybe the task is all of them because there's no filter. Compute the true value of not x element wise. Yeah, so it should be 1, I think. Oh, not logical. It's kind of confusing actually. Because if it's a logical not and the value is a 0, does that mean it's a 1 that returns? Logical not is applied to the element of x. Location in which the result is stored, if provided, it must have a shape that inputs broadcast true. If not provided or none, or freshly allocated arrays returned. Double possible only as a keyword argument must have length equal to the number of outputs. This condition is broadcast over the input. The locations where the condition is true, the out array will be set to the ufunc result. Elsewhere, the out array will retain its original value. Note that if an uninitialized out array is created via the default out equals none, locations within it where the condition is false will remain uninitialized. I think I want to search this one. Oh, so whenever it's true, it returns false. Whenever it's false, it returns true. So it just flips the value. That's probably what it does. So whenever it's 0, it's gonna be 1 here. Very confusing to understand. It generates Boolean masks corresponding to task sets. So I think my logic is correct, but I want to clarify the specifics to make sure I understand what's going on. It's difficult because this one doesn't have whatever happens here. NP zeros. So it creates the NP array based on the length of x. Then whenever there is an integer index, it turns that to 1. The other ones are going to be 0, and then it's going to return this NP array with zeros and ones. And whenever it has a 1, is a position that exists in these 3 elements. I think what I'm having trouble understanding is, shouldn't all these 3 elements have positions, have a 1 in all the indices? Because we're passing the data frame in the beginning. Oh, it's because I'm looking at the other function. That's why I'm getting confused. I'm not analyzing this one now. I'm analyzing another one. This one. Yeah, but it's still, it takes the true arrays of n samples and futures and n samples. Yeah, so this is a matrix, I think. It's gonna be an array of arrays. The first element is gonna be, the shape is gonna be determined by the samples and the futures, which are pretty much the columns, I think, of the data frame. The futures are just the columns, and the samples are the rows. Yeah, I think that's what's going on. And then this one is just the samples, which is the target, the column with the target. Yeah, this is what's happening. So X is the data frame, Y is the column that is the target. Groups is just the labels, but I think it's just optional. We need to go to this one again. Yeah, so this catches the number of samples, which is the rows. So it's basing off the number of rows. The indices are an array, a vector with the number of rows in the data frame. And then this task mask is an array of zeros based on the number of rows. But this one is still kind of hard for me to understand. When this is going to be 1 and when it is not going to be 1. Because in my mind, they should all be 1 because you're getting the data. It's just a data frame. Oh, I think this function probably generates randomly. That's why. It's because the missing part is this one. So what this one probably does is selects somehow which ones are going to be 1s and which ones are going to be 0s. So which ones, I think it probably selects randomly the indices that are going to be for the test set. And so these ones are going to be the ones that return 1 here. And that's how it generates this vector here, which is going to be a vector of zeros and ones depending on this split here. And then when you use this, it splits based on these ones and zeros, the other ones. Yeah, the training index is going to be where there is a zero, because it's a logical knot, so this is going to return 1 when this is 0. And this is using this one. Yeah, so 1 is going to be it's kind of hard to understand. It's gonna make 2 different vectors, and based off this one, which is the baseline. And it creates on a loop. So they're gonna be different in the positions. Whenever this is 0, this is gonna be 1. Whenever this is 1, this is gonna be 0. And then it returns these 2 different samples. I think that's what's happening. Yeah, so let's go to the next one. So this is the first one. Provides train test indices to split data in train test sets. Each sample is used once as a test set singleton, while the remaining samples form the training set. Leave one out is equivalent to k-fold and split n. Leave out where. Due to the high number of test sets, which is the same as the number of samples, this cross-validation method can be very costly. For large data sets, one should favor class k-fold, class shuffle split, or class stratify k-fold. Import numpy from a Sklearn model selection, import leave one out. I think I'm gonna skip this one. I think I'm gonna try to find the one that's being used here. I guess it calls the splits for from the other one. It's probably the same from the other class. I just built in. Yeah, this one. Maybe it is more interesting to look at the compile and fit stuff, because the train test split's not that important to, because I can think about different ways of splitting as well the data. I think the more interesting parts are probably the formulas of the fitting and the layers, the way that it's being built. And so I think that's probably what I'm gonna do. I'm just gonna look at the other ones. I think the biggest issue is that I can't find these models here. And it's definitely here that the calculations are being done. No, there's no definition. I guess I can look at these three ones here. The dense is probably... Yeah, I'm gonna close these ones and I'm gonna look at the layers. And then I'm gonna start from that point and investigate from there. I think it's better. I think I have a rough idea now of how they are splitting the data. It's probably very similar. The train test split with the other one that I just saw. But maybe I should stop here now, and then I do this next time that I come. Lazily import a module mainly to avoid putting large dependencies. Contrib and ffmpeg are examples of modules that are large and not always needed, and this allows them to only be loaded when they are used. Interesting. The lint error here is incorrect. So this is just to make more efficient to load modules. Using the import lib. Update these objects dict so that if someone keeps a reference to the lazy loader, lookups are efficient. I'm gonna close this one. I think maybe this graph is the other way around, where it starts from this one and goes into the other ones. Could be possible as well. But maybe not, because this is like a funnel where there's a bunch of stuff here and then converges into these ones. Trace back. Yeah, so it's probably correct. The direction of the arrows here. Oh, maybe not. TensorFlow. And let me just go to the one that I was talking about. Oh, this is the file with the train test split. So maybe I should look at this. I think I'm gonna look at this one. Probably don't have a lot of time. Yeah, I'm gonna briefly look at this one. And then next time that I come, I'm gonna start from the layers stuff. Split arrays are matrices into a random train test subsets. Quick utility that wraps input validation and next shuffle split xy, an application to input data into a single call for splitting. Read more in the ref user guides. Array sequence of indexable with the same length divided by shape 0. allowed inputs or lists, numpy arrays, scipy sparse matrices, or pandas data frames. Test size float or int default equals none. If float should be between 0 and 1 and represent the proportion of the dataset to include in the test split. If int represents the absolute number of the test samples. If none, the value is set to the complement of the training size. Train size, float or int. If float should be probably the same thing. Random state, int random state instance or none. Controls the shuffling applied to. So this is done for whenever you want to test multiple times, because you create a seed for the random number so that you're always splitting by the same way that you did on the first time. I think that's how it works. Shuffle, whether or not you shuffle the data before splitting. So pretty much randomize more, I think. Then stratify must be none. Stratify if not none, data is split in a stratified fashion using these as the class labels. This is containing training task split of inputs. If the input is sparse, the output will be a scipy sparse CSR matrix. Else output type is the same as the input type. Sklearn. Okay. So this is the length of the arrays. So arrays is the first argument, is a pointer. So it doesn't. This is more efficient in the memory. Whenever it's called, task size is the size of the task, train size the train. And so this is just a task size here. I think it's gonna be 0.8 for the train size. So just put either one of them and it should work, I think, the same way. Then random state, shuffle, and stratify. Whenever shuffle is true, stratify is false. When stratify is true, shuffle is false. So it's pretty much the same way that works on tasks and train size, I think. We just need to put one of them and the other one is it's dependent on the initial value. If n array is equals 0, at least one array requires input. Arrays equals indexable arrays. Make arrays indexable for cross-validation. Checks consistent length, passes through none, ensures that everything can be indexed by converting sparse matrices to CSR and converting no interval objects to arrays. Intervals list data frames. Okay. Result, make indexable. So pretty much the same loop or a very similar loop as the other one that I just saw. And then it checks which to see if the shapes are equivalent or if you can do the calculations based on the shapes. Yeah, it's exactly the function that I just saw before. Or it's converting to CSR if it's a sparse for efficiency, and if it's not, it converts to an NP array. I don't think I checked this one though. I'm just gonna get the number of samples in X, make the length equal to the number of samples, which is the number of rows of the data frame. And then uses this unique. If the length of uniques is bigger than 1, raise value R. Found input variables with inconsistent number of samples. Find the unique elements of an array, returns the sorted unique elements of an array. There are three optional outputs in addition to the unique elements. The indices of the input array that... Okay, so this has to be 0. But I don't understand this really well. Oh, because the length is gonna be a list of the length of these ones. So they all have to be the same length. So if it's not unique, it means that they are different lengths. So this returns bigger than 1. And then it raises the value error. Yeah, this is what's happening. And it makes based on samples. So the number of features doesn't matter. The number of columns. All that matters is the rows, because the target has to have the same amount of rows as the test, because that's what matters. As long as one dimension of the vector and the matrix are equivalent, then you can do the calculations. But if the number of rows are different, then you can't do the multiplication. And that's how they check to see if it is the same. Very interesting. Not sure, probably not gonna remember this, but I think it's useful to understand more how it works under the hood. So gets these indexables, puts into this, then calls the same functions on the arrays 0, which is the x, I think. Yeah, because this is being passed as multiple arguments here. So x and y n groups are all gonna be in this arrays variable, which is probably gonna be a list, and the 0 index is the x. So it's pretty much calling them samples on x and making it equal to this variable. Then it calls this function using the x, test size, train size. And the default is 0.25. So if there isn't a shuffle, creates the true NP arrays with ntrain and ntest. And this goes from ntrain to ntrain plus ntest, which was created by this function here. At the end, returns chain from readable, safe indexing. Tell nose that training test is not a test, needed for external libraries that may use nose. Don't know what nose is. Use set attribute to avoid MyPy errors when monkey patching. I think I'm gonna look at this one. Oh, it's on the same file. So this is passing the x, and then it's gonna create the split based on the number, probably. Validation helper to check the test sizes are meaningful. The WRT to the size of the data. If test size is not known and train size is not known, test size equals default size. Test size type equals NP as array, test size, the type kind. So it's checking the type to see if it's integer or float, I guess. Test size should be either positive or smaller than the number of sample, or a float in the 0-1 range. Also, it's checking to see if the number of the train size, this number here, is between 0 and 1, if it is a float. Yeah, test size and train size. If it's not, it's gonna throw this error. It's pretty much checking there. If it's not either one of them, throws this error as well. The sum of test and train size should be in the 0, 1. Another error. Then here is gonna do the division, I think. In test and train. Train size not none, and train equals n samples minus n test, which is this one. So if it's a float, if test size is a float, it uses this. If it's an integer, it converts to float. And then uses this to create the train. And then it checks to see if either of them are none. And makes the split based on that. The sum of train and test size should be smaller than the number of samples reduce test size and or train size. Number of samples is the total, so yeah, it should be is 100%. Number of samples is 100%, so obviously that should be the sum of them has to be equal to the number of samples, or maybe it can be smaller as well. Not sure. Okay, so I think the only function left to see is this one. But I roughly understand it's gonna take the total. In either case, depending on which one you pass, it's gonna take the total of samples and subtract the one that got from this one or this one, depending on whether it's a float or integer that you pass as the train size or test size. And I guess it doesn't need to be, the sum of them doesn't need to be equal to the number of samples. It can be smaller. So if you pass both a test size and a train size, it can be smaller than the number of samples. As long as it doesn't surpass the number of samples, I think you can do whatever you want. And if you just pass one of them, the other one is going to be the remainder. Yeah, because it's going to be number of samples minus this one. So when you don't pass this, when you just pass the test size, the train size is going to be 0. So it's going to be the equivalent, the remainder of the other one, I think. Returning the ceiling of x as an integral. This is the smallest integer bigger or equal to x. So it pretty much rounds it rounds test size times number of samples if it is a float. So if 0.2 number of samples is going to be, let's say 100%, so this is going to be 80%. Oh, and it's passed here. Trying to remember when this is called. Oh, number of samples is the length of x, I think. Yeah, it's gonna be the amount of rows that you pass in the initial phase. And this is gonna be equivalent to number of samples on this one. and does all the checks and selects here. If it is a float, it rounds up until the closest integer. And if it is in integer, it converts to a float. I guess this rounds down and this rounds up. That's the difference probably. Return the floor of x as an integral. This is the largest integer. Yeah, so it's pretty much the same thing, but this is rounds down and this rounds up. So if we pass both of them, yeah, it's exactly like I thought, I think. If you pass both, it's gonna be whatever number you pass minus the number of samples, which is the length of the rows. And if you pass only one of them, then it's just gonna get the remainder for the test, I think. Yeah, but it's weird because it doesn't check, it doesn't make it equal to anything. If only one of them is not known. Then converts them both into an integer and returns them. Well, I guess makes equal here. Yeah, that's the thing. Okay, I think I understand now what's going on. Yeah, because then it's gonna get these numbers from this one. So this is not the final result, it's just the number, the percentage, I think, of the final data that is gonna be this and this. And then it creates the final array with the number for the training test. And it's gonna return the CVSV class using these numbers. Provides train test indices to split data in train test sets. This cross-validation object is a merge of stratified k-fold and shuffle split, which returns stratified randomized folds. The folds are made by preserving the percentage of sample for each class. Note, like the shuffle split strategy, stratified random splits do not guarantee that all folds will be different, although this is still very likely for sizable datasets. Read more in the RAF. Okay. That size, floater int, default none, blah blah blah. So we need unsplits then. That size no. Oh, so this is the function I was looking at in the first time. So it's gonna use this split from this function after it goes through the other one. So the first one gets the numbers, makes the two arrays based on the numbers of the percentages, and then it throws into this one, which is gonna make the split, which is gonna use the the Boolean matrices with the masks in order to create the indexes of to make them the final matrix and the final vector for the tasks, I think, based on the mask matrices. I think that's what's going on here. And then at the end of all that, it returns this list from these methods, which is a built-in method from Python, I think. This is the function I was looking at before. Just gonna inherit from the other one. And y equals stratify, which is this one, which is shuffles the data if it is stratify. If not, runs this shuffle split. Don't understand really well the difference between them, but I think I'll stop here. Next time I'm gonna investigate from these layers here. Try to see. I think I will look at this tree here. I think the task split I kind of understand a lot better now. Obviously not gonna be able to memorize them, but just by looking at the things and having in the back of my mind how they are converting these matrices, it's probably gonna make it easier to build the models later on. So I think I'll open these 3 different files and see which ones look like they might have something interesting next time. So yeah, probably not gonna be streaming as well for at least a week because I want to finish all the other courses that I have to finish before I think it's the day 7th. I have until the 7th day of the next month to finish them. So yeah, probably gonna be streaming 1 week from now. So see you then.